Students, first of all, let us try to understand that what are nucleophilic substitution reactions of alkyl halides. Now, alkyl halides like alkyl chlorides, alkyl bromides, alkyl iodides, they are very good substrate. Now, what is a substrate? A substance, a chemical compound which is undergoing a substitution reaction. Since we are talking about alkyl halides, so alkyl chlorides, alkyl bromides, alkyl iodides will act as a substrate on which nucleophilic substitution reaction is going to take place. Now students, a variety of nucleophiles means other than the X atoms like halogen atoms, they can be used to generate a range of new functional groups. Now students, look at this diagram which reflects some of the important reactions that you may encounter. Now in the center you can see this is Rx. X represents any halogen atom. R is the alkyl group. This X can be chloride, bromide or iodide. Now students, all of these are the nucleophiles which are going to substitute this X atom, means the halogen atom of the alkyl halide. For example, if we are going to react the alkyl halide with cyanide group Cn negative, then you can see that the X atom have been replaced by Cn, which is a nucleophile. So one nucleophile has substituted another nucleophile. That is why these reactions are called nucleophilic substitution reactions. Similarly, you can see in this reaction we are using ammonia, and when we are going to react it with alkyl halide, you can see that an amide is formed, RNH2, an amine. So a nucleophile has replaced another nucleophile. All of these examples are of nucleophilic substitution reactions in which you can see that this X have been replaced by all these nucleophiles, generating some other functional groups or the derivatives. Students, let us try to understand that what this term nucleophilic substitution implies. A nucleophile, we already know that it is an electron-rich species which is going to react with an electron-poor species, means the electrophile. The word substitution implies that one group will be replaced by another group. Nucleophilic substitution reaction occurs when an electron-rich species, which is a nucleophile, reacts with an electrophilic carbon atom, and this carbon atom will be attached to an electronegative group. Why this is important? Because when a carbon atom is attached to an electronegative group, then it will attain a partial positive charge and will act as an electrophile. The leaving group that have to be replaced, that it can be displaced as shown in the general scheme. Now students, this is a substrate, means on which the reaction is going to take place. Nu stands for the nucleophile. It is going to attack on the electrophilic carbon atom. As you can see, it have a partial positive charge. Why? Because of this leaving group, which is an electronegative group. It is going to have a partial negative charge. Now when the nucleophile is going to attack on the electrophilic center, then this leaving group is going to depart. Now you can see that this nucleophile have replaced this leaving group, and this is why it is called nucleophilic substitution reaction. Now students, how do we know that which carbon is electrophile? The electrophilic carbon can be recognized by looking from the polar sigma bond due to the presence of electronegative substituent. For example, CCl, CBr, Ci and CO. You can see that in all of these examples, the carbon atoms are attached to an atom which is electronegative. Nucleophilic substitution reaction are important class of reaction, and that allows the interconversion of functional groups. Why students? Because this halogen atom will be replaced by another incoming nucleophile, giving another functional group. So these reactions are very important for interconversion of the functional groups. Students, there are two types of nucleophilic substitution reactions, and there are two events that are going to take place in a nucleophilic substitution reaction. The first one is the formation of a new sigma bond to the nucleophile. The nucleophile is going to make a bond with the electrophilic carbon atom, and that bond is a sigma bond. So a new bond is going to form. The second event is breaking of the sigma bond. Now which bond is going to be broken down? The bond which is between the carbon and the leaving group. It is going to break down. Now students, depending upon the relative timings of these two events, two different mechanisms are possible. Bond breaking to form a carbocation precedes the formation of a new bond. Such reactions will be called as SN1 reactions, or we can say nucleophilic substitution unimolecular. One stands for unimolecular. Secondly, simultaneously bond formation and bond breaking means both of these two events, they occur simultaneously. Such substitution reactions are called SN2 reactions or nucleophilic substitution bimolecular. 2 stands for bimolecular. Now students, we are going to discuss in detail SN1 and SN2 reactions. Students, let us apply the two events that we have already discussed on these chemical equations. The first one is representing substitution, which is SN1 reaction, means nucleophilic substitution unimolecular. Now students, you have to concentrate on the sequence of events. Look at this chemical equation, the first one, in which the carbon to chlorine bond is going to be broken down. It is a slow reaction. It is going to ionize and give you a carbocation, and the leaving group have already departed. Means the bond breaking is going to occur first. Secondly, in the second step, the nucleophile is going to make a bond with this carbocation, and you can see that bond formation is the second step. So bond breakage is the first step. When bond breakage occurs before the bond formation, then such reactions are called nucleophilic substitution unimolecular. But students, if both of these two events, means the bond formation and bond breakage, they occur simultaneously, then such reactions are called nucleophilic substitution bimolecular or SN2 reactions. Students, we are going to discuss in detail SN1 and SN2 nucleophilic substitution reactions along with their mechanism.